Unit 34 exercise. For question 1, which is a question from IAL, first, you are asked to calculate the heat energy absorbed. Again, with our famous equation, mc delta T, and the answer will be here. Part 2, number of mole of ammonium thiocyanate used in experiment. First of all, get the molar mass is 76.1 gram per mole. So the number of mole can be calculated by mass over molar mass, like this. Finally, you were asked about the enthalpy change of reaction. Now, you should pay attention is the final answer should be in terms of kilojoule per mole and two significant figures, which is a little bit different from the DSE. This question is not easy because it involves the definition of delta HR. Here is, according to part 1 and part 2, if 0.2 mole reactant is used, then will contribute 2,300 something joule. So what about 1 mole of ammonium thiocyanate is used, right? This value is when 1 mole of ammonium thiocyanate is used. But if you study our equation here, according to the definition, 2 moles of thiocyanate will be used. So we should times 2 to our equation, because whenever we repeat the equation 1 mole times 2 moles of ammonium thiocyanate will be used, then the answer will be positive 23 kilojoule per mole. And here you can see we got two significant figures and the positive side. Next one, question 2 is a DSE questions. First of all, you will calculate the enthalpy change. Calculate the number of mole first. Again, mass over molar mass. And here is our answer. Next one, with mc delta T, we can find the energy release. Again, you can see here, you are feel free to include 3 grams of calcium oxide or not. Both answers will be accepted. Finally, the delta H is the amount of energy released over the number of mole. As the final answer requests you in terms of kilojoule per mole, we should convert our energy in kilojoules, and it will be minus 77 kilojoule per mole. And of course, if you use 50 cm cube or 50 gram instead of 53, then your answer will be around minus 72.6 something. Also accepted. Next one is why there is difference between the theoretical value and the experimental value. So again, you have plenty of choice. But I would recommend you to write down something more besides heat loss to surrounding is why. Here we suggest that because the polypropylene cup is a poor heat insulator. Or you may say because the cup is not covered, so heat loss easily. But here I give you another one, which is tailor-made in our case. That is, the calcium oxide we used is not fresh enough. They may react with the moisture in air before the experiment to form calcium hydroxide already. Next, first of all, you are supposed to use extrapolation to find the temperature drop. And in part A2, so you were asked to calculate the enthalpy change of solution that is dissolving the ammonium nitrate, mc delta T for the energy change. You should be careful is the mass this time is 21.8 gram and the specific heat capacity is no longer equals to the pure water. So the energy change will be positive 600 something joule. What about the number of ammonium nitrate we use? I found the molar mass of ammonium nitrate at first, and here is the answer. Or finally, is the delta H. Now remember, this is an endothermic reaction, so the positive sign should be kept like this. Next, suggest one way to keep the ammonium nitrate solid dry during the storage. Now, many of you just mentioned use calcium hydroxide or calcium oxide or use drying agent. Well, this is not enough, because how can you interpret the term use, right? So here is a better answer. You should mention keep the ammonium nitrate solid with the drying agent, for example calcium oxide or silica gel, in the desiccator. Now of course you should not use corn sulfuric acid as a drying agent, right? So please make sure you include the drying agent and desiccator. Question 4 is a thermic reaction. Now first, we complete and balance the equation first, like this. Next one is you are supposed to draw the labeled enthalpy level diagram. As this is an exothermic reaction, so the reactant's enthalpy level should be higher than that of the product. Now, first of all, don't be lazy. You should include every single reactant and product, include their coefficients. The second one is, what about the arrow sign? The arrow sign is pointing downward. A double arrow is not accepted. Question 5. First of all, what is the general formula of the homologous series that methane belongs to, which is alkane? Here it shows. And the second one, you are supposed to mention what kinds of bond is breaking and forming during the process. So we complete it one by one. And here you can see we will consider whether the bond is single or double. So please do not confuse. And finally, why the combustion is exothermic in terms of breaking and formation of covalent bond. Now, we can conclude it like this. First of all, bond breaking we need energy absorbed, and bond forming is energy released. Finally, because this is an exothermic reaction, so we can conclude that the energy released is larger than the energy absorbed. And here shows. Question 6. This question is a bit tricky because we try to eliminate the effect or the heat capacity of the calorimeter by carrying two sets of chemical reaction. The first set is burning methanol, the other set is burning heptane. So you were asked, calculate the enthalpy change of combustion of heptane by using the data from methanol. So first of all, you are assumed heat capacity of the calorimeter be C. For step 1, here shows, if 1 mole of methanol is burned, then it will give you 700 something kilojoule. But now we only have 1.58 over 32 mole. Okay, doesn't matter. Finally, the calorimeter increased the temperature by 18.5 degrees Celsius. For the second reaction in step 2, similarly, the delta H, which is the enthalpy change of combustion of heptane times number of mole, will equals to 25.8 degrees Celsius increase in temperature of the calorimeter. After we combine these two equations, here is the final answer. Next one, besides heat loss, now this time you cannot say heat loss to surrounding anymore. Is there any source of error? The most typical one, 2 of them. The first one is, and the second one is, of course, you may say this is not in standard condition. but try not to mention the calorimeter has zero heat capacity, because by question 1, actually we try to eliminate the effect of the calorimeter already. So this is not a good answer. Or we can say, in part 1 calculation, we have considered the heat capacity of the calorimeter already by using the blue equation in part 1. Question 7. Now, first step, we have done it in the lessons. We got the highest temperature change is 33.1 degrees Celsius. Because we can find the highest temperature change from the graph. And here is 58.0 cm3. We can find the number of mole of NaOH by using m times V equals to number of mole. We can find the number of mole of NaOH, but also along with HCl, because they have 1:1 in mole ratio. Then the concentration of HCl will be over the total volume, like this. Next one, calculate the delta Hn with the initial temperature. So first of all, MC delta T. Don't forget to have a negative sign. And next one is, what is the amount of water formed during the reaction? It's 0.058 mole, right? So we can get the answer like this. Well, part C, so please refer to your notes for the definition of delta Hn. Question 8. So in case there is a solution W can react with magnesium ribbon, so what kind of functional group they should have, either in formula or in word. COOH or carboxyl group are accepted. Next one is, when 2 moles of NaOH can react with 1 mole of W, so 2 possible structure of W. These 2 are most typical one, but there are some weird examples. For example, one of the functional group is COOH, the other can be an ester, which is an alkaline hydrolysis. It is acceptable. Now, B2, many of you got the incorrect answer, or I can say he or she cannot get the full mark. So first of all, delta Hn, again, the definition, no problem. The problem lies, how can you, in terms of Y, for this reaction? But you should be careful, the word is deduce. That means not only answer, but also the reason behind the answer. How can you get the value? You can see, because 2 moles of water is given here. So in case you want to find the delta Hn, yes, the value is easy, Y over 2. But why? So please copy down what you have just concluded. The value is Y over 2 because 2 mole of water is formed in the equation given. Question 3. So given a strong acid, strong base neutralization give you minus 57 something kilojoule per mole. So what will be the case if we use weak acid? More negative, less negative, or equal? Well, that's good because you are given 3 choice, then your choice will contribute 1 mark. It should be less negative. The reason behind is there is weak acid, so part of the energy will be consumed by ionization. So you should be careful. They have strict requirement to the word ionization. Those students who mention dissociation will not given marks. Question 9, 2021 questions. Again, why this is exothermic in terms of bond breaking and bond forming. So copy the answer from the previous year, but this time in terms of breaking and forming covalent bond, please mention which bond is forming, which bond is breaking, And here is the answer. Energy used in breaking bonds. I emphasize there are 3 types of bond: CH bond, NC bond, or OO bond from oxygen is less than that of energy released in bond forming. Again, 3 types: CO double, NO double, or OH bond. Now, if you forgot to mention what kinds of bond is breaking or forming, then 1 mark will be deducted. And next one is calculate the enthalpy change of combustion. Here is the equation, mc delta T. And next one is divided by number of mole as usual, like this. There's nothing special. We have tried many times already, right? Again, don't forget the negative side. Question 10. First of all, find the maximum temperature change. And yes, it is not possible for you to use different color in the examination. So please make sure your pen is or your work is clear enough for the marker to observe after your paper is scanned and shown on the screen. There is the highest temperature, right? And the temperature change should be 2.1 degrees Celsius. Oops, yeah, we forgot the chemical equation. And here is part B. So, calculate the enthalpy change of neutralization again. And here is mc delta T minus 800 something joule. But this time we need to emphasize, okay, HCl is in excess, so we need to calculate the amount of calcium hydroxide used. Now, but don't be happy, because if you refer to our previous equation, actually 2 moles of water is formed during the reaction. So it do not fit the definition of delta HN. So we solve it one by one. First, what is the enthalpy change when 1 mole of calcium hydroxide is used? Like this, right? But sorry to say, because when 1 mole of calcium hydroxide is used, 2 moles of water will be generated. So the delta HN should be half of that value, which is minus 65 kJ per mole. And here is the tricky point. That's the end of the Unit 32 exercise.